Hey guys, my name is Trevor Sullivan and welcome back to my video channel. Thanks so much for joining me for another video in our Rust programming tutorial series. Now, the topic that we're going to be focusing on in this particular video is actually a tool that you can use in your Rust workflow in order to write more robust and higher performance code. Plus, you can actually learn more about the Rust programming language by using this tool. Now, typically this tool called Clippy is included with an installation of Rust when you use the rustup installer in order to install your Rust toolchain, which includes things like the rustdoc CLI, the cargo CLI, and the Rust compiler, which is rustc. Now, Clippy is a really cool tool because it is able to kind of inspect your code files and make recommendations on what you can improve in your code project. So ultimately, when you use Clippy to help provide guidance to you when you're writing your Rust code, you get more code consistency, you get recommendations about maybe new techniques in your Rust code that you didn't even know were possible, and you can also ensure consistency across a team environment. This is a really important thing when you start to have multiple team members that are all working on a similar project. One team member might prefer a certain syntax or they might use a certain method, but a different team member might use a different mechanism in order to accomplish the same task. And so by using Clippy, it kind of provides these guardrails to make sure that your entire team is on board and following the same best practices for writing Rust code. Now, as I mentioned, Clippy is part of the Rust toolchain. However, if you installed the minimal version of the Rust toolchain, then this component may not have been installed. In fact, it probably wasn't installed if you installed the minimal version of the toolchain. But thankfully, if you're using the rustup installer here, you can simply specify that you want to add the Clippy component into your Rust installation, and that'll get Clippy installed in your environment. And then you can go ahead and call Clippy anytime that you want to. Now, you can use Clippy at the command line while you're building your Rust code, but you can also incorporate Clippy as part of your CI/CD pipelines. So anytime that one of your team members does a git commit and then git push up to your code repositories, as part of that CI/CD pipeline that gets kicked off during that push event, you can execute the Clippy utility. You can set up some configuration options as well in a configuration file, as well as command line parameters. And then if Clippy catches any issues inside of your code, you can actually abort execution of your pipeline and have the developer go back and fix whatever code issue there is, and then go ahead and update, do another git commit, git push, and fix those types of issues. So you can use Clippy as kind of a learning tool. You can use it as a gatekeeping tool in a good way, not a bad way. And you can help just ensure that your team is writing consistent and high quality and high performance code. Now, there are over 650 lints. I know the Clippy documentation book here says 600 lints, but if you check out the open source repository here for Clippy, you can see that in their latest version of their README, they do boast having over 650 linting rules available. And when we talk about linting, linting is basically just when a software utility inspects your source code files and looks for any potential enhancements that you could make or any potential errors that you could run into, and this helps you to catch errors as early in your development life cycle as possible. You don't really want to get, maybe 20 minutes into a build process and then realize later down the line that you have an issue with your code. It would be a lot better to get that immediate feedback from Clippy early on in the development process so that as soon as you run into some kind of warning or error inside of your code, you can go back, fix that, immediately push the updated code, and get that feedback as quickly as possible. So I highly recommend using Clippy, and you might be thinking as a Rust beginner, well, why do I want to introduce more guardrails? Why do I want to introduce more issues when I'm already trying to learn the Rust programming language and maybe hitting a bunch of brick walls? Well, again, this is going to provide guidance based on these linting rules So the rules are configured to not only detect issues, but also to provide recommendations and to deepen your understanding of what those specific issues are, so that the next time that you write similar code like whatever you caught previously with one of these linting rules, you can write code in a better way. So I actually think that getting these errors and warnings from these utilities is a positive thing in your learning cycle of Rust, because you are able to have a tool that's providing those guardrails for you. So look at this as something that's going to kind of come alongside you and help provide better recommendations on how to write Rust code, rather than looking at it as an inhibitor or something that's blocking you, because it's actually helping you ultimately to write better Rust code. Now, these 650 lints, those are a lot of different rules, and they are categorized into these default categories in Clippy. So we've got Clippy all, we've got Clippy correctness, we've got suspicious, style, complexity, performance related things. And by default, there are certain warning or allow levels that are applied to each of these categories. So for example, if you look at something around the cargo manifest files, right? Those by default are going to be allowed, but if you want specific rules to be caught as warnings or actually block execution and error out when you run the Clippy utility, then you can change the default level here from allow to maybe warn or deny. We'll talk a little bit more about those levels in just a moment. But basically, each of these categories are broken down into these individual rules that target very precise recommendations inside of your code. So it'll look for certain patterns in your code, it'll look for certain method calls, it'll look at maybe the number of arguments that you're passing into a function, or maybe how long your function code is, and things of that nature. And some of these things actually have customizable parameters on them too. There's actually a separate configuration file that we can use in Clippy to kind of tell it how to apply these different rules. So if we take a look at this configuration section right here, there's a special file that you can add into your project called clippy.toml, or you can hide it with .clippy.toml, and it's going to look for that file in your project directory, or you can actually specify an environment variable for where to locate that configuration file, or you can specify this manifest directory where your cargo manifest is located. But by default, it's just going to look in the current directory wherever your shell is pointing to. So that's kind of the easiest way to use it, rather than having to set one of these environment variables. But inside of this configuration file, it's basically just an INI or TOML kind of file format here, but it doesn't really have any headings. So you don't have those square brackets with the headings like you do in the cargo.toml file. All we do is we set a variable, and we set the variable to a certain value. And you can find all of these input configuration options, or these variables, and the supported values for them in the documentation for the actual lints themselves. So if we take a look at the README over here and then click on this link to go to the linting rules here, that'll take us directly to this Clippy lints page here. And this is going to show you all of these individual rules. And if you'd like to, you can actually filter them by group here. So we could say, I would just want to see things related to my cargo.toml configuration, or maybe I want to see things that are performance related. So I'll just click on none and then include the performance group right here. And as you can see, there are quite a few performance related rules right here. And then once you find a rule, like maybe let's take a look at toString, for example. So if you are using the println macro here, and you are taking a string as input, and you call the toString method on it in order to convert it to a string, this rule is basically checking for that and saying, hey, it's not necessary for you to call toString, because the thing that you're passing in to this println macro already implements the display trait. And so therefore, the println macro is able to decipher how to convert that object input as a string representation. So basically, it's just going to recommend that you eliminate this toString method call, and that will provide higher performance code. Now, another nice thing about Cargo is that it can actually fix some of these issues automatically. Unfortunately, I didn't see any kind of specificity in here to determine if a rule is automatically fixable or not. So you'll kind of have to play around with the individual rules to figure out if they are supported for automated fixing. But there's a parameter called dash dash fix that you can pass in to the Cargo Clippy command, and that will automatically trigger a fix for any of these issues for you if they support an automated fix. Also, we've got these linting levels. So I mentioned these briefly earlier and said we'd take a deeper look at them. There's allow, warn, deny, and none, but there's actually a couple of other levels as well. So if we go back and take a look at the Clippy documentation and take a look at, I think it's under the usage section here, maybe. Let's see if it's in here. Let me just do a quick search and search for levels here. So in any case, the levels allow us to specify things like force warn and force deny, which is also known as forbid as well. I'm not entirely sure where that is in the documentation here, but there's a force warn and a forbid option that you can set as well. And those are not displayed inside of this interface here, but you can use those to basically prevent somebody from overriding those particular rules. Now, how do you actually enable these rules? Well, there's really two different ways that you can do this. Number one is you can actually go directly into your source code and you can use an attribute in order to configure these lints. And the other thing that you can do is actually specify the linting rules on the Clippy command line. So when you run cargo Clippy to invoke the Clippy utility, you can actually specify which rules you want it to either warn or deny the access to in your code. So this example right here is going to show you how to basically deny all rules. This is an attribute syntax that you would use across an entire module or across an entire crate if you are specifying that in your lib.rs file. So you can use this attribute-based syntax, but you can also use this syntax down here where we can allow with dash capital A. There's also a dash dash allow that's kind of spelled out. I generally prefer to use the spelled out parameters just because they're more clear if you're reading your code, because dash A is pretty ambiguous. That could mean a lot of different things. It could mean all, it could mean allow, it could mean a whole bunch of different things. So I generally like to spell these out. Also, dash dash warn or dash capital W is how you can specify a warning level. And if you want to deny something, you can actually use dash capital D or dash dash deny and then specify the name of the rule. And you'll notice that when you specify the name of a rule, it does need to be prefixed with Clippy and then a double colon here, and then you can specify the name of the rule. So if you're looking at the list of lints in this documentation right here, just remember that you need to use the lint name prefixed by Clippy double colon if you're using it inside of the command line when you run cargo Clippy. So in any case, we're going to look at a couple of these rules and how we can incorporate them into our code. And we'll take a look at the parameters on the Cargo Clippy CLI tool so that you can understand how it works in practice, as well as the automated fixes that we can apply to our code in order to fix changes or fix issues in our code without having to go manually seek out those issues and fix them on a line-by-line basis, which can ultimately save you a lot of time when you're working on a large project. But before we jump into our example, I just wanted to invite you to subscribe to my YouTube channel here at youtube.com/Trevor Sullivan. I'm an independent content creator, so any kind of support that you can provide to this channel is extremely helpful. In the pinned comment below, I'll leave some links that you can use as affiliate links, and you can optionally use those to do some online shopping. And if you make a purchase through there, I'll get a small portion of the proceeds of that particular sale. So please consider doing that. Also, you can go out to my channel here and find the Rust programming tutorial playlist. We're up to 28 videos, so this will be video number 29. And there's a whole bunch of Rust concepts inside of this playlist here that we go really into depth and hands-on with. So feel free to check out this entire playlist here and, pick up any knowledge that maybe you have a gap on. If you need threading knowledge, if you need to learn about iterators and how to kind of work with the different methods on there. If you want to learn about hash maps and hash sets, there's a whole bunch of different topics in here. So feel free to go through this playlist. Also, if you learned something from this video, please leave a like on the video. That helps to kind of promote this video in the algorithm, and also leave a comment down below and just let me know what you thought of this video, the style and format, and also let me know what other kind of Rust topics you want to see on my channel and in this playlist right here. So with that out of the way, let's go ahead and spin up a brand new project, and we'll take a look at how to use Clippy. So I'm going to switch over to my integrated development environment, which is Microsoft Visual Studio Code. I'm running it on Windows 11. That's my development workstation locally. But as you probably have seen in my earlier videos, especially the first video, I talk about how to set up a remote development environment against a remote Linux server. So I actually have a virtual machine running with LXD, which I have another playlist series on, setting up LXD on a bare metal Linux server. And this virtual machine is just running a headless Ubuntu server distribution using the latest LTS distribution of Ubuntu. And I have VS Code remotely SSH'd into that virtual machine. So when I run a shell here and do things like rustc, then this is actually going to be running on a Linux distribution rather than on my local Windows system. And this is really nice because it allows me to kind of switch back and forth between different systems, and I have a consistent development environment. So if I go use my laptop upstairs, I can just load up my SSH session that I was working on my development workstation in my office, and I can just pick up where I left off. So I'd strongly recommend that you invest some time into learning how to set up that remote development environment, because in the long run, it'll make you a more productive developer. But as you can see, I have Rust installed here. I've got the latest version of Rust 1.72.1, and Rust up is how you typically install Rust, especially on a Linux server. And if we take a look at our components here, we want to basically verify that Clippy's installed. So what we can do is say Rust up, and then go into this component context, and then we can say list installed and available components. So just do a rust up component list, and then if you do a shift control F, I think, or maybe just control F in here, and then search for Clippy, you can see that the cargo component's installed, the Clippy component is installed, Rust docs are installed, Rust source is installed, and there are a bunch of components that I don't need on this particular system that aren't installed, but any of these bolded items here that have installed at the end are going to be present on your system. If you want to inspect the file system to verify that Clippy is installed, then you can actually just go to your home directory. So we'll say $home, and we'll go into the .rustup folder here. Then we can go into the tool chains folder right here. And you can see I've got the stable tool chain. I don't have nightly installed on this system. And then if we go into that specific tool chain version, we can take a look at bin. And inside of the bin directory, you should see that there's a cargo-clippy binary that you can execute. So if we execute the cargo CLI and then run Clippy afterwards, then that's going to be how we invoke this utility. So if we do cargo clippy --help, you can see we've got this --fix parameter right here that allows us to automate fixes in our source code. It also shows us how to use this attribute here to allow or deny or warn on certain linting rules in our code. And then these options right down here are going to allow us to, at the command line, when we actually run cargo clippy, we can specify warn, allow, deny, and forbid as additional customizations for which rules we want to enable or disable, right? And then don't forget about the configuration file. We'll take a look at some specific configuration options as we go through the individual rules. But if we do something like, let's search for args down here and go to all lint levels. And we want to look for one called the number of arguments. So if we take a look at, I think it's number of arguments or argument count or something like that. Too many arguments. So let's do that. Too many arguments. So in this particular rule here, you're basically just inspecting the number of arguments in a function, and it has this configuration section. So when you're looking at a lint rule for Clippy, you want to look at this configuration section and see if it specifies any additional configuration options. And then these configuration options are what you can place into that toml configuration file specifically for Clippy, and that will customize how this specific rule executes against your code. So let's go ahead and write some simple code in a project. So we'll start by creating a project directory in here. We'll just do a make dir and then specify a folder like lint-test. And then we'll go ahead and open that up. So I'll do Control K, Control O, and we'll open up the lint test folder in our editor, which will reload the window and get us connected to that specific project. So now we have this empty folder, and we'll just do a cargo init in this directory. And now we have our simple scaffolded out binary project here. You could also do a cargo init and specify --lib if you want to create a library instead with lib.rs. But for now, I'm just going to go ahead and create a binary application with a main entry point. So now what we can do is start by specifying some rules in our code using attributes. So let's actually use this example right here of too many arguments. And let's say that we want to prevent or deny a build of our code if we have too many arguments. So we want to use the deny attribute in our code. So we do a hashtag and then an exclamation point, and then we can say deny. And then inside of this deny attribute, we can specify which linting rules we want to block the build on. So in this particular case, we can just hit Control Space and see a list of all of these different rules right here. And so we want to use the too many arguments rule. So we'll pass in Clippy, ;, and then too many arguments. And that way, if we have more than by default 7 arguments, you can see right down here, the documentation says it defaults to 7. So if we have 8 arguments in our function definitions, then that will breach this rule and cause an issue. So for starters, before we actually apply the customization, let's declare a function called testlint. And inside of the function declaration here, let me just call it so that it's not complaining about us not calling it here. And inside of the function definition, we're going to specify 8 arguments. So we'll say arg1 is a u8. And then I'll just duplicate that 2, 3, 4, 5, 6, 7, 8 times. And we'll just rename these to arg2, arg3, arg4, arg5, 6, 7, and 8. All right, so now we have 8 input arguments here. And of course, it expects 8 inputs. I'll do 1, 2, 3, 4, 5, 6, 7, 8. And so now I should ultimately be blocking the build based on these arguments here. Now it looks like I have a little syntax error here, so let's see what's going on. Right curly brace. I have a left one over there. I have a right one over there. Not really sure what's going on here. Let me just do a cargo build. And it looks like we have an unclosed delimiter somewhere. So where is that? Oh, I killed off the right curly brace for main. So let's go ahead and include that. And so now we should be getting an error or a warning indicating that we have too many arguments here. Now, this is just complaining about unused variables here, but let's see if we can force it to fail. So if I do a cargo and then Clippy command, that's going to invoke the linter. And as you can see, when I invoke Clippy with cargo Clippy, it's going to look at these attribute-based rules that we've declared in our source file here, and it's going to parse those. It's going to look for any configuration options for those linting rules, and then evaluate my code using static analysis in order to see if there's any issues. And as you can see, it says error, this function has too many arguments. It says the rule indicates that we want 7. Again, that's the default. I haven't customized that in my Clippy configuration, but we actually have 8 arguments. So now let's say that I want to customize the number of arguments that are going to cause a breach of this rule. Also, one more thing really quick. If we do echo $? Here in bash, you can see that we get an exit code of 101. So if you're in a CI/CD pipeline and you're doing automation in there, you can just inspect that exit code and see if it's 101 or non-zero. And that will indicate that there was some kind of error that occurred in the Clippy linting. And then you can just immediately abort the build process, abort the CI/CD pipeline, and that'll save you a whole bunch of CI/CD minutes. If you're using a SaaS vendor to do CI/CD and you're paying by the minute, like with GitHub Actions or maybe Circle CI or Travis CI, something like that. And so that's a really nice way to just kind of detect if there were any issues. Also, we can just change this to warn and say, instead of denying, I want to just warn on that. And then if we warn, we're not going to get a non-zero exit code. We'll just get a 0 exit code. But in the standard output, we're still going to see that there was some recommendation here. So now what we're going to do is to customize the number of arguments. So the default for this too many arguments lint rule was 7 arguments. So we put 8 arguments to breach the rule. But let's say that we wanted to customize that and say, I want a maximum of about 4 arguments. So again, we're going to grab this configuration option right here that allows us to customize this specific rule for too many arguments. And we'll create a new configuration file in our project here. We'll call it .clippy.toml, and you don't have to put the period at the beginning. It'll look for clippy.toml as well. And then all we need to do is paste in that setting and set it to the value that we want. So our functions can have a maximum of 4 parameters. And if we breach that, then we're going to warn on that issue, or I'll actually change it back to deny. So now we'll do cargo Clippy. And as you can see, we have 8, but it wants only 4 now. So that's how we apply that customization option to this lint rule. So now if I eliminate these extra arguments here, and I'll just put them in a comment in case I need to put them back. Now we can eliminate these from the inputs here. And now this should satisfy the rule. So if we do cargo Clippy again, you can see that we're getting warnings about unused variables, but we're no longer getting the warning or the denial, rather, the error saying that we have too many arguments. Of course, if we went back and added arg number 5 again and reran cargo Clippy, then we are going to get that error along with the 101 exit code. So that's how we can apply the attribute for denying this particular rule to the entire crate, because the hashtag exclamation point applies to the parent. So main.rs's parent is the crate itself. So this should apply to our entire crate. And we can also apply things to individual entities as well. So if we want to do that, let's say maybe we want to allow unused variables, right? So let's do something like unused, and we'll search for unused argument, I think. Let's do a search for argument or unused variable maybe. And I'm not seeing that show up here, but there is one for allowing unused variables. I'm not sure, maybe that one's not actually a Clippy rule, but let's check out some other types of warnings that we might have right here and see if we can find another one. So I think another one is actually the toString. So let's go ahead and search for toString right here. And I think that that was going to be a warning, a performance related category warning. So let's go ahead and try to use this inside of an example. So if we have a type that implements the display trait and we call toString on it, it should catch that as a warning. And as you can see, there's no configuration section here at the bottom. So there's no additional configuration options for this particular setting. So what we're going to do is just define, what is this, toString. So we'll define another test function here. We'll say test string. And let's also fix this. We'll go ahead and remove that 5th argument there so that that's happy. So what we can say down here is that we want to allow unused variables. So let's say let x equal 5. We could also use arguments as inputs, like arg1 is a unsigned 16-bit integer. And so as you can see, we get unused variable, unused argument, and unused variable again right down here. So if we want to allow unused variables only on this particular function here, we can just use a hashtag without the exclamation point, and that's going to apply to the item directly following the attribute definition. So we could say allow, and then specify unused variables down here. And I don't think this is a Clippy rule because it doesn't get prefixed with Clippy here. And I also couldn't find it in the Clippy docs here. So just be aware that that one I think is just built into Rust here. So now you can see that those warnings immediately go away. If we run cargo Clippy here, then you can see we just get function test string is never used, but we don't get those unused variable warnings like we do for this function called testlint up here. So if we comment out that attribute and rerun cargo Clippy, we should get an unused variable here on the test string function now. And previously it was only reporting on unused arguments or variables on the test lint function. So it's complaining that we're not using the argument arg1 on the test string function, and it's complaining that we're not using the x variable that we declared inside of the test string function body. But the rule that we wanted to test out was the toString rule right down here. So what we'll do is go ahead and just do a print line operation here. Let's do print line. We'll specify curly braces, and then we'll pass in, I think, X. I'm not sure if it explicitly implements display, but I'm guessing it probably does. We could also just use a string value like hello from Rust, Trevor, and then we'll pass in X. Yeah, that's fine. It's a string. And then we can do dot toString here. So now we're taking a string slice and we're actually converting it into a heap allocated string by calling the toString method on it. So now if we do cargo Clippy, then you should see this warning right here that says toString was applied to a type that already implements the display trait. So this is, again, a performance-related thing that's saying, hey, you don't actually need this toString method call here, so go ahead and eliminate it, and your code will still work perfectly fine, right? So once we rerun this here, we no longer get that warning, and that's helping to improve the performance of our application by providing that linting guardrail by default. Again, the default level for that particular rule is to warn. So it's not going to allow it by default, but there are some things that are allowed by default that you can enable warnings or deny operations for, such as these right here. If you just filter by the allow rules right here, then these are types of things that are be allowed by default, but you can enable them in your configuration. You can actually set a warning attribute or a deny attribute. So in order to specify these rules at the command line, that's kind of the second way. So far, we've taken a look at the attribute-based syntax here that applies at the crate level, the parent level, and the individual function level or individual struct level, enums and traits and that kind of thing. But if we want to include some of these rules in our CLI here, we can do cargo Clippy, take a look at the help, and then we can warn, allow, deny, or forbid certain things inside of our code. And the forbid is going to be the most strict because that's going to basically ignore any overrides that you have. So that's kind of the most strict option if you want to forbid things in your code. But let's just say that for now, we want to maybe allow, let's allow the toString function right here. So we'll do x.toString again, but this time we're going to go ahead and specify that we want to allow it in our Clippy CLI rather than specifying it as an attribute-based syntax here. So what we'll do is say cargo Clippy and then put dash dash here because that will prevent any arguments from being passed to cargo. Anything after the dash dash will be interpreted by Clippy itself, not cargo. And so what we want to do is say we want to maybe allow the Clippy and then what's it called? Let's do a filter on toString warnings here. So it's called toString in format args. So we want to basically do Clippy : and then toString in format args. So let's see, can I copy that from somewhere here? I'll just copy it here. We'll click that button and then we'll do Clippy : and paste that in. Oh, of course, when I copied it included the prefix there. So now if we run this, you can see that we don't get that particular warning. If we run without that parameter, we do get this warning saying that toString was applied to the type that already implements the display trait. But if we run with the dash dash allow here, that will eliminate that warning from popping up. Also, if we wanted to change that warning into a deny, we could simply specify dash dash deny instead of allow. And so now this is going to cause an error during the Clippy invocation, and that'll catch that rule early. And now we get a 101 exit code. So again, we can abort our pipeline. So those are really the two ways to apply things. We can do it at the attribute level for kind of a global scope here across the entire crate. We can do it, I think that works at the module scope as well. So if you have a submodule, you could plug this attribute into there. I think that would probably work. And then we can also use this syntax here in order to apply to the element directly following. And when I say element, of course, I'm referring to functions, traits, enums, structs, and things of that nature. All right, so let's take a look at the quick fixes or the automated fixes with Clippy. So one of the things you might have noticed from earlier is that when we do cargo clippy -- help, the cargo CLI actually has a -- fix option. So you want to pass this into cargo, not into Clippy. So you want to put it before the double dash, and that's going to be an option that gets passed to cargo. Anything after the double dash gets passed to Clippy specifically. So if we do cargo Clippy -- fix and then plug in our Clippy options after that, then we can apply automated fixes. So let's see if there's an automated fix that'll remove this invocation of the toString method. So right now, the way things currently stand is that if we run with a deny here, we're going to get this error on toString here, because we changed it from a default warning into an explicit deny on our command line. But now we're going to go right before these double dashes right here. We're going to apply -- fix to that. And as you can see, by default, it's going to warn us about uncommitted changes, but very similar to doing a publish operation, which I don't think we've covered yet, publishing crates to the crates.io registry. We can specify this parameter here called allow dirty, and this will prevent us from needing to commit our changes with running this command. So we can go ahead and just say allow dirty. I think that's something we passed to Clippy, not cargo. So no, it is actually cargo. So let's move that before the double dashes here. We'll put the double dash after that. And now we should hopefully have a fix here. So as you can see, that automatically fixed our code. We can do Control Z to undo that change. And then if I just bring this down a little bit here and rerun the cargo Clippy command, you can see that it automatically fixed that issue for me, so I don't have to fix that, because maybe I've got 100 or 200 different spots in my code where I was calling toString unnecessarily. That'll take care of fixing all of those instances for me so that I don't have to go manually seek them out and resolve them. So that's a real time saver that you get with the Clippy CLI tool. So as you can see, it is pretty powerful here. There's lots of different rules that are spread across these different groups right here. So this is really nice that it's grouped, because if you want to look for performance related issues, if maybe you're having some performance issues and you want to try to resolve specifically performance issues, you can just filter by these performance based rules here and see what you can find. Let me just clear that search. And so all of these rules right here are performance related, and we can just run Clippy against all of these different rules and see if they apply. And also, if any of these rules have configuration options like this one here, we can also go ahead and specify those inside of our clippy.toml file. So feel free to play around with Clippy. In fact, I strongly encourage you to get some hands-on time with Clippy. Maybe run Clippy against an existing Rust project if you've already started building your own Rust project, and just see what kind of warnings or errors it throws. Also, make sure that you incorporate Clippy into your CI/CD workflows as well. If you're using something like GitHub Actions or GitLab CI/CD or maybe OneDev CI/CD, go into your configuration files and add this Clippy command as an early step in your process to catch these errors as early as possible in your pipelines, so that you're not waiting a long time for the build to complete and only then realize that you have some issues. So strongly encourage you to play around with Clippy, play around with some of these different rules, play around with some of these different configuration options. You can use the CLI, or you can use the attribute-based syntax in order to apply the rule changes. So if you decide to go the CLI route, of course, you would be specifying these CLI parameters in here in your CI/CD configuration file. Whatever script it is that you're running in your CI/CD pipeline, you'd basically just add in all these deny and allow parameters inside of your CLI script that you're calling Clippy with. And then, of course, you can always check for that exit code of 101 to see if there is an issue or not. And then you could either abort the pipeline, or you could just maybe send an email or a Slack message to your development team indicating that Clippy caught some issues, and then maybe proceed with the build if you're comfortable with that approach. But again, it's entirely customizable to each and every project that you are writing in Rust. So in any case, I think that's everything that I wanted to cover around the Clippy utility. I strongly encourage, especially beginners, to use it because it really does help guide you on writing better code. It helps you learn more about the Rust language and the standard library, and it's just a great tool to have in your back pocket to help improve the efficiency of your Rust builds. So again, if you learned something from this video, please leave a like on this video. Please leave a comment down below. Let me know what you thought of it, and subscribe to the channel. Click on that bell icon so that you get notifications when new videos are published. And I'd love to hear your thoughts in general on this entire playlist. Thanks for watching, and we'll see you soon. Take care.